Okay, so this is review. At the very top of this is actually this whole page. Monomial, what is a monomial? First of all,
1.
Very good. Mono means 1. So they gave you some right there, 9 monomials, and they want you to include, to write in here some things that monomials can include. So write a couple things. That's good. That's fun. Write a couple things, and then I'll run through.
Has to do with numbers.
Good. You can definitely include numbers, yes. Okay, that. They also can include variables, exponents, zero, that's good, zero's a monomial.
Square root.
Yes.
Numbers.
Negatives, good. Okay, so that's a pretty good list. It's not everything. That's a pretty good list. All right, so then if you look at these 4, these things are not monomials. So let's see if we can compare that to the list that we read about and figure out why they are not monomials. What can a monomial not have?
Square root of a variable.
Very good. That's exactly right. So this one has a square root, but it's a number underneath. This one is a square root with a variable underneath. So that's the difference. Okay, so I'm going to see if we can come up with a reason for each of the 4. So that explains that one. What about this one?
Fraction of a variable.
A fraction of the variable in the bottom. See, if you look at this one up here, we have a fraction, 5/3 of y squared, but the variable's not in the bottom. And we talked about this earlier in the year. If it's written like that, with the y next to the fraction mark, that y can be moved to the top, but it is not on bottom. So in this case, the variable's on bottom, so that can't happen. Okay, and then the reason for these 2 could be the same reason. No addition or subtraction. These are separated by addition and subtraction. Probably. I don't remember, but I can look. It's recent. Okay. So using the monomials above, identify examples of the following definitions. A blank is a monomial with no variables. That would be, here's a monomial, here's one with no variables. What's another name for that? It is, but okay, wait. Yes, but so is this. This is also a monomial with no variables. And these 2, they have the same name. Anybody know what you call it? There's no variable?
A number.
That means it never varies. Because it doesn't have a variable, so it never changes. What's a mathematical word that means never changes? Thank you, it's a constant. So a constant is a monomial that has no variables. So up on our chart, 2 was one of those, 5/3 was one, negative 8.5 was one, 0 is a constant. They can't change because there's no variable on them. So if they're in a problem, it's just going to stay there just like they are. Okay, so in that would be, so let's look at a couple of the monomials that we have that have variables. This has a variable, and this is a variable, and this is a variable. And they have a numeric piece, or a numeric factor.
I would say the number is like variable.
Yes, and what's it called? It has a name.
Coefficient.
Very good. In a monomial, the coefficient so the 2 is x. Et cetera, et cetera. You get it. It's the number part of something that has a variable. Okay, the last one. And this one, I don't know, I honestly don't know if you guys talked about this in ninth grade or not. So, the blank of a monomial is the sum of the exponents of the variables only. It's called the degree, and I don't know if that's something that y'all learned in ninth grade or not. They keep changing the teaks around here, I can't remember. Okay, well, it's a super easy idea.
Well,
The degree comes from the variable. So you look at the variable and then you just tell me what the exponent is. So on this particular monomial, it has a variable of x, and I just look at the exponent on the x value. Well, there doesn't appear to be one, but there is one. If anything, right, it's to the first degree. Which means the degree of this one is 2. Now here's where you have to be careful, because on the negative 8.5 I actually have 2 variables. So my degree is not 2, but it's 3, because there's one on the x next to y, so that's what it is. So this one would be 12, and 0, and 0. And the main reason for those two things being 0 is because they don't have a variable. And the degree comes from the variable, neither of those have one. Alright, so far so good? So that was new. The rest of this stuff is old information. Okay, so we're going to review simplifying monomials. You do it all the time, so do not let the fact that we're reviewing it confuse you. You do this stuff a lot already, so you already know how to do this. But there's a reason why they're going to do the expanded version as well as the reorder and all that stuff. If you can simplify monomials really well without doing all that, then don't worry about it. But some people don't, and they need to see why things happen, so that's why they're doing this. So this is our example, multiplying 2 monomials. They give you the monomial 5x squared y cubed and 4xy. And we're going to multiply them. So the first thing they did was they expanded each one of them. They wrote the 5 times x, because that's what x squared means, right? X times x. And y to the third is y times y times y. So they wrote it out expanded. Then they did the same thing with the 4x piece. They went ahead and factored this. I don't know why they did that. I think that's silly. But they went ahead and factored the 4 as 2 and 2. And then they wrote x, and then y, 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 y. Everybody good? Okay, so then they took the time to reorder it. Numbers with numbers, x's with x's, y's with y's. Still separated by little dots because that means multiplication. So when they do that, that gives me 2 times 2 times 5. So 2 times 2 times 4 times 5 is 10. And then I have x. Thank you, because I can't multiply. It's because they did that dumb factor. Okay. Then I have x to the, how many x's do you have? 3, right? 1, 2, 3. So x to the third. And y to the 1, 2, 3, 4, 5, 6, 7. Y to 7. Okay. Well, that's the long way. That is what you're doing. The shortcut version. These are the numbers I was given, and I end up with 20. Multiply the coefficients. And then how did you get these exponents? 3 and 7. Add the exponents. Okay, so really, I don't know anybody who expands them for multiplication purposes. We are all pretty good at following the rule. The rule is rewrite the base, add the exponents. So in this case, the way they've written it, my base happens to be A. So you rewrite the base and you add the exponents. And that's the rule. And most of the time for multiplication, we just use the rule, because most of us are pretty good at that. Division is the one that gets some people. And so sometimes the expanded version can help. Especially, and you'll see in just a little bit, especially when the problems get a little bit different. So, they're doing the same thing, but this time we're dividing. So, they expanded the top. They went ahead and factored this all the way down to prime factors. Do you remember doing that in 6th grade? Factoring things all the way down to prime factors. Did you use factoring tree? Remember that? No?
Yes.
Factor all the way down. Anyway, that's what they did. I don't really know how they did it. But 18 will break down to 2, 3, and 3. Then they wrote the x's, 1, 2, 3, 4 x's, and 1, 2, 3 y's. Did the same thing with 6 broken into 2 and 3, and then 1 x and 2 y's. Now here's why they do this, and here's why it's helpful with division. Any number over itself is what? 1. And any number times 1 is itself. So when you have 1's in a multiplication problem, like these are all multiplication problems, you can just cross through them, right? So 2 over 2, that's gone now. And 3 over 3 is not really gone, it's 1, but it's the same thing. And then I have an x over an x, and get rid of that. And then I can get rid of some y's. And now I can just rewrite all that's left. All that's left on top is a 3. Actually, there's nothing left on bottom, so it's all on top. So I have 1, 3.
3x to the third.
X to the third, y, because you have this 1 y left.
Oh, shoot.
And that's it. Okay, so that's the long way, although it comes in handy sometimes. That's the long way, but the shortcut version, see, I had 18 and 6 to begin with, and now I have 3. Divide the coefficients.
Well, we're gonna have a test over these. Just doing that. Right?
Yes, but don't think it's going to be easy. You'll see in just a minute. So divide the coefficients, and what shall we do to the exponents? Subtract. See, this is advanced algebra 2. So it must get more advanced. Okay, so the rule for division, remember multiplication and division are inverses of each other. So the rule for multiplication is rewrite the base, add the exponents. What do you think it is for division? Rewrite the base and subtract the exponents.
This is so hard.
Okay, so yes, I know. But what makes it hard is it's so easy, I know, but what is going to make it hard is we have to do all the rules together, and that's when things get confusing. So it'll get confusing, I'm just going to be honest. Okay, so then there's this rule, which I know you learned, but it's not one that you use a whole lot in Algebra 1, but we use it a lot in Algebra 2, and then after that you just use it all the time, and it starts to be a point where it's not really a rule anymore. So it's just something you do. If you have a negative exponent, like this, that cannot be left in a final answer. Negative exponents are only for processing. It's just for us to get to where we're going, and then when you get to the end, you have to fix that. You can't leave it in an answer. So this is the rule. If it's a negative exponent, it has to move downstairs. So, or actually, the way I like to explain it is, he doesn't really like where he lives. He's very negative. See, he's real negative about where he lives. Whether he lives upstairs or downstairs. So, I'll show you what I mean in just a minute. So, the only way you can make him happy and positive again is to let him change apartments. He's either going to move from the downstairs apartment upstairs, downstairs. So let me show you what I mean, and then we'll come back to this one. So let's say you have x to the negative 2 over y. Okay, so Mr. X is very unhappy. He currently lives in the upstairs apartment, and he doesn't like it up there, not one bit. But y is just fine where he lives, because he doesn't have anything negative on him. Everybody with me? So Mr. X has got to move downstairs. He's going to join y, move to the downstairs apartment, and that will make him oh so happy. So now I have y over positive squared, because he's happy now, but you have to indicate that he's downstairs. This is the upstairs apartment. Nobody lives in there.
Does that become 1?
Yes? Very good? Okay, so now let's say you have this. X cubed, y to the negative 2 over c to the negative 3. Who is unhappy?
Multiple.
Z and y. X is fine where he lives. So Z does not like the downstairs apartment, he's going to go upstairs. Y does not like the upstairs apartment, he's going to go downstairs. X is fine right where he lives, so he's going to stay in the upstairs apartment. So you get x cubed, z cubed, y squared. Now everybody's happy. You good?
Yep.
Okay, so now, what if you have, let's see, you got x to the negative 2y. Who's unhappy? Just the x that's upstairs. So he's going to move downstairs, and his brother already lives down there. So now how many x's live in the downstairs apartment?
1.
No.
No.
When he moves downstairs, he turns positive. So
5.
5. So it becomes y over x to the 5z.
Silly.
Yes? Everybody get it? Alright. Okay, so now back to the rule. So here's the rule. If it is just a base with an unhappy exponent like this, you just move them downstairs. That's what this rule says. So this becomes, so right now, he is currently in the upstairs apartment. So you gotta move him downstairs. And in order to show that he lives downstairs, you have to put a 1 up there. You can simplify that. 5 squares. So it's 1 over 2. Is everybody okay? Okay, so this X is unhappy in his current living situation. He lives in the upstairs apartment. Gotta climb the stairs. Such a pain. He doesn't like it. He moves downstairs. Now he's glad. That shows he lives downstairs. Yes? Everybody good? Okay, so then the reason they wrote this one, this is where I think that whole expanded thing makes more sense. Because if I wrote BBB up here and then 9Bs, what would you do, please? Just cancel. But what they want you to do is use the rule, which is rewrite the base and do what with the exponents? Subtract them. So that would be b to the 3 minus 9, which is b to the negative 6, which means he is unhappy and needs to move downstairs. So you get 1 over b to the 6, yeah? Very good? But you would have gotten the same thing had you done the expanded version, which sometimes I prefer. So if you had, and if you do it this way, I am all for it. So if you had done this, and then cancel these 3 out, you would have ended up with 1 over b to the 6. Same thing. Yeah? 2 ways of doing the same thing. I don't care which way you use. Just get right answers. Okay. So there's that rule. That's your negative exponent rule. Just remember you can't ever leave a negative exponent in a final answer. But it's fine while you're doing processing, okay? Because we're about to get set up. Okay, other exponent rules. This is called raising a power to a power. Anybody know what you do when you raise a power to a power? What do you do with the exponents? Multiply. So this would be, that's where this comes from, A, B, and N. So this would be 5 to the 6. This would be x 20. This would be b to the negative 12, which you then have to fix because you can't leave a negative exponent in the final answer. Got to move them to the downstairs apartment, whatever. Any questions so far? Do y'all remember all this? These are just the exponent laws. Put them in micrograde. Okay, so this is just a reminder. If it's in parentheses and has an exponent outside of it, then that means the exponent belongs to everything inside. It's kind of its own little distributive property. So the m goes to both a and b. So that would make this 5 squared over 8 squared. Which you could simplify. 25 over 16. That means this one would be x7.
Or do you use that?
You didn't do, I didn't do either. I just put it on there.
No, on.
Oh yeah, no, this is raising a power to a power. So you multiply. So it would be b to the 15, c to the 10. Everybody all right? Same thing here. This m belongs to all of the pieces inside. So it has to be a to the m, a to the n. Now, here's the one that will get you. And I promise you, it'll get all of you at least one time. That 2, the one on the outside, this one, it goes to the 5 also. So it's really 5 squared x to the 4th, which is 25 x to the 4th. You can't forget about the coefficient. It goes to the coefficient as well. This one would be x to the 6, y to the 12. All right, this is going to be 4 to the 3rd, x to the 6, y to the 12. 4 to the 3rd is 64. X to the 6th. So don't forget about the coefficient. That one has to be raised to the power as well. All right, so far so good? Now, yes?
You want us to always simplify that 4 to 3?
You know what, that's a good question. If it's a reasonable number, but if this was like,
8,000.
yeah, if it's like a huge number, I'd leave it. But if it's a reasonable number like 64, then yes. Okay, so just in case anybody is still like completely lost, one thing that you can remember about exponents. Okay, so y'all know PEMDAS. These are the operations. Whatever your operation is of your original problem, your exponents are always one step behind. So, let me write that. So, for example, up here in the top, when we had I look at this problem and I know something in parentheses next to something in parentheses. That operation.
Oh, dear God.
That operation is multiplication. So overall, it's a multiplication problem. But my exponents are one step below whatever my operation is. So if my operation is multiplication, my exponents are added. If my original problem is, for example, this type of problem, now some people might look at that and say that is multiplication, but it's not. That's an exponent problem. So what my original operation is exponents. My exponents are actually one step below that, which would be multiplying. Okay? If it's an addition problem, what are your exponents doing? Step below.
What?
What's down here?
Oh,
Nothing, because that's exactly what your exponents are doing. Nothing when you're adding. See? Look here. 2x squared plus 3x squared is what?
5x squared.
5x squared, because your exponents do nothing. Okay. So there you go. All right, so now, here's where it gets not quite so simple. Actually, number 1 or 2, those are easy. It's not till number 6. Things get a little more difficult. Okay, so number 1. What overall original operation is happening in this problem? So what should your exponents be doing? Adding, because multiplication, one step below multiplication will be addition. But your coefficients, they have to do what the operation is doing, because they're not exponents. So my coefficients are going to be multiplied, so that would be -8. Is everybody okay so far? Rewrite the base and do what with my exponents? Add them, so that would be a to the 4th, b to the 5th, c. All right, that was easy. On number 2, what operation is this asking you to perform? An exponent. So the coefficient has to follow the exponent rule. It has to be raised to the exponent. That'd be 3 to the 3rd. You may know what that is. Thank you. And if my original operation is exponents, then what is happening to my exponents? They're being multiplied. So
What is that, an x to the 6?
X to the 6. Now here's one of those where you could write out 11x's if you wanted to.
Yeah.
Write out and cancel them. Or you could rewrite the base and do what with exponents? Subtract. Good. So 11 minus 5 is 6. Alright, so now starting on number 4. Here's where things get a little bit tricky.
Okay.
Here's where you have to follow PEMDAS. I have more than one thing happening in this problem. So what has to happen first? The exponents, because that's what PEMDAS says. Parentheses, but nothing that can happen inside the parentheses. And then exponents. So this has to be taken care of before the multiplication is taken care of. So I'm going to rewrite my problem as 6x squared y cubed. I didn't do anything to that. But I'm going to rewrite this as x cubed y cubed. Alright, now it's just a multiplication problem. So I'm multiplying my coefficients, because that's the operation. 6 times 1 is 6. And what am I doing with my exponents? Adding them. Okay, now, on number 5, there's a couple of different things you can do, because the rule about negative exponents doesn't really fall anywhere in PEMDAS. It's just you gotta fix that kind of thing. So it's like, do I fix it at the beginning, or do I fix it at the end, or when should I fix it? It doesn't really matter, as long as you fix it. So I could, there's several different things I could do here. I can take that A that has a negative 3 on it, and I can move him to the downstairs apartment, because he's currently in that. I could take the whole thing and move it downstairs and put 1 over the parentheses 6A, because the whole thing's unhappy. Or I could distribute the negative 3 to the inside pieces and then deal with the negatives. It doesn't matter. In the end, you will get the same answer, no matter how you do it, as long as you just keep going until all your negative exponents are gone. So it doesn't matter, and to be honest, I don't have a preferred way to do it. Sometimes I do it one way, sometimes I do it another. In this particular instance, I am going to go ahead and multiply them. It's not really going to change much, but if I multiply negative 3 times negative 3, that's going to make this one positive, so that fixes this one. But it makes this one negative, so it messes that one up. So it's not like it matters. So I'm just going to go ahead and put the negative 3 on all pieces first, just because, I don't know. Don't want to. It doesn't make it any shorter or easier if you chose to do it a different way. So the first thing I'm going to do is 6 to the negative 3, A to the positive 9, B to the negative 6. And now I'm going to take care of the fact that I have negative exponents and I cannot leave a final answer like that. So my 6 is unhappy and my B is unhappy. And they're going to move downstairs. The roommates in the downstairs apartment. So it'll be A to the 9 is perfectly fine living upstairs. These guys are going to move down 6 to the 3, B to the 6. Anybody know what 6 to the 3rd is off the top of their head?
36 times 3.
36 times 6. Jeez, that's what I thought. 216, B to the 6. 6 is similar in the sense that I've got negative exponents down here. I can move those up. I have x's over x's. I can do the whole subtract thing. Or I could do this first. It really doesn't matter what you choose to do first. And it's going to be the same answer no matter where you start. So it doesn't matter to me which thing you want to do first. Let's take care of the fact that I got x's in both places. X's here and y's here. Let's fix that first. Which is technically division, because I'm subtracting exponents. Or in my head, I expand it and go, okay, there's 3 x's on top and 5 on bottom, which means that there were 2 left on bottom. So there we go. Like that's how my head works. But if your head doesn't work that way, that's fine. Just do the subtraction. Okay, so I'm going to do the division inside first. That's what I'm deciding to do. If you want to do the square first, you can do that. But I'm going to do the division inside first. So negative 3 divided by this coefficient, which happens to be a 1, leaves me negative 3. That's going to leave me x on bottom, x squared on bottom, and then this guy would go upstairs and live with his brother, so the 8, y, the 8 on top, z on top. Is everybody okay so far? Did I lose anybody? Yeah, yeah. I just knew this guy, in my head, I just went, okay, that's 3 x's on top, 5 on bottom. So that's going to cancel 3. And leave 2 x's on bottom. Or you could say, I'm dividing. So rewrite the x, subtract exponents. 3 minus 5 is -2. That means then with the upstairs. Either way. And then on the y, it was y to the -2. So I wanted to make him happy. So he moved upstairs and became happy. So that was y6 and y2. So that's y to the 8 on top. Yes? And then z just moved upstairs. But you're not done because now I have to take care of the square issue. Do not forget, you have to square the coefficient. So it's going to be -3 squared, y to the 16, z squared over x to the 4. And then I can fix that. That's 9. Y to the 16, z squared, x to the 4. Okay? Alright, so then there's 2 word problems, but they're super easy. Got a rectangle that has a width represented by 3x squared y to the 6th and a length represented by 8x to the 5th y to the 3rd. What expression can be used to represent area of a rectangle? How do you find area of a rectangle? Very good. Area equals length times width. And I happen to have the length and the width, so that would be 3x squared y to the 6th times. And now we just need to simplify that. So my overall, I am multiplying, right? So it's going to be 24. And so that means my exponents are adding. So x to the 7. Alright, don't let this trip you up. It's a triangle. This time they gave me the area. Okay, so first of all, formula for area of a triangle. Base times height divided by 2. So now let's plug in what we know and leave off what we don't know. So I know the area. They gave it to me. So 14. I'm going to put that right here. 14x to the 4th, y to the 9th is the area. I do not know the base, so I'm going to leave it as a b. I do know the height, 7x squared y to the 5th, and that still has to be over 2. Now, if we're going to solve this equation for b, we want b to be by itself. What would you do first? Multiply by 2. Very good. Clear the fraction. Get rid of that 2. So I'm going to multiply this side by 2, and if I do that, I have to multiply this side by 2. Which doesn't change anything about my exponents. That just gives me 28x to the 4, y to the 9. Now I'm trying to get this b by itself, so what should I do now? Divide. Yeah, divide by all that, and divide by all at one time. And then all you got to do is simplify. So 28 divided by 7 is 4. I've got 4 x's on top and 2 on bottom. In your head, you could expand and cancel. Or, you're dividing. What would you do with exponents? Subtract. So that would be 4x squared. Y. Everybody all right? Okay. This is all review. You know. All right. So now you have problems just like what we just did. Simplify. So go.
Yes, I do.